All right, welcome back, everybody. We're actually going to cover this section 5.7, which is called or deals with partial factoring. And you might be thinking, okay, we learned how to factor in the previous unit sections where we went through the different types of factoring: common, difference of squares, simple trinomial, and decomposition. But not every quadratic is factorable. Sometimes the x-intercepts are ugly numbers like decimals. And if you can't factor it, then that means up to this point, what you guys understand is that if you're looking for the vertex, you can't get your x-intercepts to then get the axis of symmetry because you can't put it in that nice bracket form. But what we can do though, one of the methods, and this isn't the method I would say we use very frequently, but it's a method that I'll go over right now, is you can use what's called partial factoring to determine that axis of symmetry. And partial factoring, what it allows you to do is to solve for two x's that are at the same height. That's all it allows you to do. And then once you get those two x's at the same height, that's how you get your axis of symmetry out of that. Because we don't care whether those 2 points at the same height are the x-intercepts. As long as they're at the same height, we know that the axis of symmetry is in the middle of those 2 points because parabolas are symmetrical. So in essence, what are you going to do? You're going to take your standard form, which is useless, and if it can't be factored, up to this point, you would be stuck if I asked you for the vertex. You wouldn't know what to do. But you can now express it after today's lesson in partially factored form, which means you're going to pull out the x from just the first two spots, just the x. Notice the a number and an x is left behind, and the b number is left behind in a bracket. The c is never touched, so that's what we mean by partially factor. So it's not common factoring. You're not common factoring everybody. The c is kind of forgotten about. Just leave them at the back. Then what we do is we take that x bracket ax plus b section, and the c guy is still there. We make it worth c. So we set it to the same height as whatever c is. So if this is 15, we make it equal 15. If it's negative 27 at the back, then we make it equal negative 27. So whatever number is your c, your y-intercept, that's the number you make it equal. Because what happens is when you bring the c over, you're going to get c minus c. And that's what gives us 0. That's what we want. We want a difference of 0 between the c's. So now what happens is we set this first section, which is just x, to equal 0. And we set the bracket section to equal 0. And that gives us two x numbers that are the same distance from the axis of symmetry. So what we can do now is we can now solve for the axis of symmetry because now we have these two x's that are at the same height. And then once we get the axis of symmetry, then it's just like before. You sub in your h back into the equation, doesn't matter where you stick it, and you get your k, and that's how you finish off vertex form, remembering that the a is the same in standard as it is in vertex. So that means you just steal the a value and stick it in the front. Okay, so let's try one you're going to see, and then you can decide for yourself if you like it or not. So the question says determine the maximum value. So what it wants k. That's what that's asking us for. It wants the y value of the vertex. And it gave us this quadratic. Y equals negative 3x squared plus 12x plus 29. The problem is it's not common factorable. I can't pull out the 3 from all 3 spots because the 29 ruins it. So because it's not common factorable, it's not difference of squares, of course. It's not a simple trinomial because I'm stuck with the minus 3 in the front. 3 times 29 is 87. There aren't two numbers that multiply to 87 and add to 12. So it's not factorable. Okay, so if you go through all your factoring techniques, you're going to find that none of them work. So that means its x-intercepts are probably very ugly decimals. Or maybe it doesn't even have x-intercepts. Maybe it doesn't even touch the x-axis. So that would make sense then why it's not factorable. So what we do is we pull out the a value out of the first two guys, pull out the x, not the a value. Pull out an x from the first two spots only, leaving the a value behind. There we go. So I'm going to take out an x from him, and I'm going to take out an x from him, which just leaves a positive 12. Notice we're not touching the 29. The 29, again, like I said, is forgotten about. So all I did was steal an x from the first section, and all I did was steal an x from the second section. Okay, now we're going to make it equal 29. So put a 29 on that side. And then what happens is when you bring this 29 over, you're going to get 29 minus 29, which is a long way of saying get it to equal 0. And I can do that because I set the height to be whatever I wanted. I'm trying to find 2 points on this parabola that happen to be now at a height of 29. That's all I'm doing. So that means now I can solve for x here and x here. So we're going to solve for x. So x itself, set it to 0. That's easy. And the other section, make it equal 0, solve for x. So bring the 12 over to the other side and divide both sides by 3. So these are the x numbers that have the same height on the parabola. So I know the axis of symmetry is smack dab in between these two distances. So my h, right, my axis of symmetry is x1 plus x2 cut in half, s plus t cut in half, 0 plus negative 4 cut in half, which is obviously negative 2. So that's the axis of symmetry, but it didn't ask us for that. It wanted the y value of the vertex, not the x value. So now I'm going to sub negative 2 for x to get k. So you might be asking, well, where do you stick it? Just stick it back in the original equation, right? That's probably the easiest. Y equals negative 3 bracket negative 2 all squared plus 12 times negative 2 plus 29. Work it out. Y equals, that's 4, that's negative 12, negative 24 plus 29. So 36 plus 29, negative 36 plus 29 is negative 7, I believe. So what we just found here, guys, is our vertex. So the vertex is negative 2, negative 7. So now I can answer the question. Determine the maximum value. Therefore, the max value for this parabola is negative 2, negative 7. So what that did is it allowed us to solve for, oh, I didn't answer the question there. I gave you the vertex. I should just give them minus 7 as the answer. I'm getting ahead of myself. There we go. So it just wanted the maximum value, which is just the y value of the vertex. Now, because we know the vertex, I can write this now in vertex form, right? So vertex form, I would steal the a value, which is negative 3, because that's not changing. And I would write it as y equals negative 3 bracket x plus 2 all squared minus 7. So there's vertex form for the same parabola. So now we have standard form and we have vertex form. We don't have factored form because we weren't able to solve for the x-intercepts because it wasn't factorable. And like I said, notice, hopefully by now you'll notice why. This is a parabola that opens upside down. Okay, that's why he has a max. So if you want to picture it, again for my visual people, we have a vertex of negative 2, negative 7. So here's negative 2, here's negative 7. I'm just pretending. And he opens down. There he is. Do you see why we couldn't factor him? Because he never touches the x-axis. He opens down and is shifted down. A and K have the same sign. So because A and K in this case are both negative, this guy's never touching the x-axis. So that's why this guy has no x-intercepts, no real roots. So without any real roots, no wonder he wasn't factorable. So he doesn't have a factored form. Factored form doesn't exist. So no factored form. So he only has two names. He has a standard form name and he has a vertex form name. All parabolas have at least those two. Not every parabola has factored form. All right, let's try this one more time so you can get the hang of it. Here's another one that's in standard form, and it wants us to do it in vertex form and then graph it on the grid down at the bottom. Okay, so let's give this one a go. Again, we try to do it in full factored form, but again, you notice that you can't pull out the 2 because the 5 ruins it. So it's not a simple trinomial. It's not common factorable. It's not a difference of squares because there's 3 terms. And if you go 2 times 5, you get 10. There aren't two numbers that multiply to 10 and give you 8. So there's no decomposition option either. So again, 2x squared plus 8x plus 5. So not factorable. So we still always try to, but I'm not going to spend 10 minutes trying to factor something that isn't factorable. So what I'm going to do is I'm going to partially factor. Because what it's asking us for is to sketch it. So in order to sketch it, I want vertex form. I want to get the vertex out of this graph in order so I can plug it in and do my step pattern and finish the graph. All right, so partially factor means we pull out the x from here and from there only. So the x gets dragged to the front, leaving the 2 behind, an x behind, and an 8 behind. The 5, forget about them. Set y to equal 5. So 5 goes on this side. And again, I'm showing all the little baby steps. Bring the 5 to the other side. And this is how you get 5 minus 5. And this is how you get 0. And then once you get this point, x himself is 0. 2x plus 8 equals 0. 2x equals negative 8. X equals negative 4. It's the same thing as before. Look at that. Same. The two x values to get our a of s. Axis of symmetry is 0 plus negative 4 cut in half, which is negative 2. And then I'll continue over here to get k, because now we have half of our vertex is negative 2 comma something. So to get k, we got to sub in. Now again, I'm just going to go back to the original 2 bracket negative 2 all squared plus 8 bracket negative 2 plus 5. So wherever I see the letter x, I now make it a negative 2, just the table of values method, plug it in. Out pops 4, 8, negative 16 plus 5. Again, symmetry in the numbers. Negative 8 plus 5. Look at that. Negative 8 plus 5 is negative 3. So my vertex now is negative 2 on the x, negative 3 on the y. So that means my vertex form is y equals, steal the a value, because it's the same a value, bracket x plus 2 all squared, because you want the person to go to the minuses, so you're going to put a plus here. Don't forget to square the bracket and a minus 3 at the back. So we have standard form, which tells me the y-intercept is 5. That's basically it. And we have vertex form. That's all I need. I only needed vertex form to graph it. So remember to graph the 3 points or the 3 steps. Remember, so as a review to graph, you get out the vertex. Negative 2, negative 3. Go there. Plot that point. Negative 2, negative 3. Which way does he open? Well, it's a positive in the front, so he opens up. All right, that was step 2. Step 3 Okay, step 3 is our step pattern. So I know the parabola goes up like this. The step pattern. So A value is 2, right? So that means normally from the vertex, we went 1 over, 1 up. And normally from the vertex, we go 2 over, 4 up, right? Those are our normal numbers. What's going to happen is these normal numbers now are going to be, these heights are going to be times 2. Times 2 times 2. 1 times 2 is 2, 4 times 2 is 8. So that means from my vertex, I'm going to count 1 number over, go 2 numbers up. 1 number over, 2 numbers up. So you should be at -1, -1. Back to the vertex. 2 numbers over from the vertex. 1, 2. So now you're sitting on the y-axis. Go 8 numbers up. 1, 2, 3, 4, 5, 6, 7, 8. You should be at 0, 5. Surprise, surprise. 5 was the y-intercept. So you should be at a height of 5 on this graph. So right away, here's one arm. And because of symmetry, I can get the other arm by just mimicking what was happening if I didn't want to say count the same way on the other side. 1 over, 2 up puts me at that height, right? It should match the previous guy on the other side. And 2 over, so I'm now at -4, 8 up. I should be at -4, +5. And again, start at the vertex, smooth, arrows, done. And there's our parabola. He's vertically stretched by a factor of 2. That's why he looks skinnier. Make sure you put your arrows, and of course, you should also label with either name. It doesn't matter if you call him by his vertex name or his standard form name, because it's the same parabola, so it doesn't matter. So this is to show you why we use this method called partial factoring, because when something isn't factorable, it doesn't mean that he doesn't have x-intercepts. In this case, the x-intercepts are some random decimals. I have no idea what they were. So that's why we weren't able to come up with them, right? 2 numbers that multiply to 10 and give you 8, they're decimals, so who knows? There is another method to get those numbers, those decimal numbers, which you're going to learn in the next unit. But if your goal is to get the vertex out of it in order to be able to factor or to answer maximum minimum kinds of questions, then this partial factoring method is actually pretty useful. And it's not that much different than what you were doing before, right? The only difference is in the beginning, how you make it equal the number at the back to make it equal 0, and then you solve for each individual little x. But getting the axis of symmetry and subbing in the axis of symmetry, so you get your h and your k, that's the same as before. And remember, the a value is just borrowed from standard form over there to use it in vertex form. The graphing hasn't changed. So again, your 3 steps to graphing: pull out the vertex, plot that, determine whether he opens up or down. So pay attention to that part. And then the step pattern. Counting from the vertex, 1 over, 1 up. From the vertex, 2 over, 4 up. How does the number in front affect these new heights? Right? So in this case, we multiply our original heights of 1 and 4 by the 2 that's sitting in the front to give us 2 and 8 respectively. And that's how I counted on my parabola. So definitely practice again, and I'll see you in the next class.